Hello and welcome to another episode that I am starting to call Arduino Modular in a week. This will be the third and last video about the SITH, my sample and hold module, except for a build video as well. There is coming a build video for this. So third episode, it has taken 3 iterations. We started with this one, with all the stuff that happened there. Then we came to this one, which was very close to the final thing that we have today. But this on the back was for the final feature that I'm going to talk about today, as well as showing off the final module as such. And when we talk about features, something that happens a lot when you do a project like this is feature creeps. A lot of people who do projects and want to end up with a product talk about that. It can happen fast, as with, so we had the first version here. I wanted to add this little thing that was necessary to have. And when I added that, I quickly added this button here to have so I could hold the signal manually. And that's a quick feature creep. It just goes in there. It was super fast to put it in there. Did have to move things around, but not a big deal. And it came out and it worked, and fine, we can leave that behind. And then we have and it's just just a spur of the moment. And then we have those things that when you're doing a project, so if you watch the other videos, any of the time when I show this off on the modular, I use the marbles Y output, which is basically a random signal that is just a wave that is just moving up and down and in just a chaotic random way. And in those videos there, as soon as it went below, when the red LED there went red, the signal just stopped and it just kept that tone until it became green or positive again, and then it started to change the effect. And that's the thing with this one, with this one, was that it could only handle positive signals. So a lot of people on my Discord server had tons of great ideas for using the an Arduino pin to mix the signal in. I'll show you a bit of the schematics. But I ended up just using, do I have those here? There's a blue one. Just these dual switches with 3 positions. So one with those 2 connected, one in the middle with nothing connected, and one like that connected. And I'll get to why I did that. That means that this one now up here has the switch that is internal noise source, external 5 plus 5 volts source, and external -5 to +5 volts. So with this switch we can now have the whole range of voltages that we want. And then but this one was a feature creep with that it irritated me so much I really had to have it. So now, and this took quite a long time to perfect or find this version that I was happy with and that worked with all the quirks of this one. so this one works. And then when we talk about things that have a microcontroller on them, the feature creeping can go on forever, because you can make new firmwares, you can add alternate functions and stuff like that. And just a few days ago, when I did one of the final codes and compilated one of the final codes for this, and realized that it is 3K big, this sketch, and there's so much room left on the Arduino Nano. So then I started to implement a way of adding an alternate feature, Easter egg, call it what you like. So you put these in a special configuration and press the button, and then you have another function of it. For this not to go on forever and ever and ever, I've just written down some of the ideas I had in the code. Of course, there's many things I didn't think about, but so I've implemented the code in this to be able to have an alternate function. So anyone who wants to add to this code or change this code, make a branch on the GitHub, can do that with any function they want for this. I have a simple random that checks the signal and gets it in sync, but still random. So kind of a synced Bernoulli gate, something like that. Yeah, I'll show you that as well. Before we move on, I'd like to say thank you to my Patreons who support me over on Patreon, who got to see the first draft of, or the third draft of this video. This video has been so difficult to make. I don't know why, but it's, yeah, I'm trying to make a third video about the same module and trying to make it somewhat relevant and interesting. It's not easy. But anyway, so they get to see that and a bit other stuff. So thank you very much for supporting me over there. And with that, let's go and look at in the computer first about this little switch here. There were some very good ideas over on the Discord server. Twig had a few ideas, but it incorporated minus 10 volts that you passively mixed here, and then buffered and amplified, I believe, here to go to the positive side. And then also Luther found this very neat contraption using a digital one of the pins of the Arduino, and by adding or removing that, we have, so we could, with a push button, so we would need one pin for the push button and one pin for this digital out here. That way we could, so this is when we have 5 volts, and then this would be when we had plus 5 volts and minus 5 volts. So because I didn't have any pins left because they're all used for the DAC, so I couldn't use this. And then I tried a bunch of different ideas of using the internal external switch that I already have, that I actually, if we look here, we have 5 volts, but then it's also connected to ground, and that didn't work. So, but we had 5 volts, so we could maybe use this 5 volts and connect this in parallel with a digital input. But I just how I routed that, the signal just went the other way, so I didn't manage that. So instead I thought of adding another switch that just switches between plus 5 volts, is uni mixed here and into the analog read of the Arduino. As you can see, it is plus 5 volts. Everything is above 5 volts there. And this is when we had a voltage between 0 and 5 volts, and it wouldn't have to mix in the 5 volts to get it down. Or sorry, up above 0 volts. So this is then and then I would have another switch. And again, I like the design. I didn't want to add another switch. So that's where the dual switch came in. So this here is the switch then. So we choose internal or external, and that is plus 5 volts. It is external, and ground, it is internal. The input pin here in the code, it is input pull-up. So this here is not shown as a 3-position switch, but it is. So when it's in the middle, it's not connected to anything, and the input pull-up of this pin will take care of it. So it will still think it is plus 5 volts. So it's still external, but without the 5 volts from this one down here, adding into the mixer sample plus 5 volts. And then when this one is in the middle position, it is not connected to anything, and this is not connected to anything. This one is input pull-up, and this one just doesn't add voltage to the input CV. And then in the lowest position, this is again nothing, doesn't matter, because we're pulling this to ground, using the internal noise, and we're not using this switch at all. And this is what the final panel then looks like. I switched places for the track sample and the internal external switch, because I thought this internal noise, external, this has to do with this up here, the input. Then we have the min-max knobs. We'll go through that in a minute. And then we have the hold, the button, the input, and the LED. And then we choose here for track or sample output, or also noise output in the track output if we don't have a hold in place. And the output. So very simple panel. Had to do it a bit wider than the first version, but I'm really happy how this turned out. So let's go through this module and the capabilities it had. So first of all, it is just a simple sample and hold, just like you would any other sample and hold, with an internal noise in this case. So the most basic patch you can do is you take a trick from the marbles in this case, and you get the hold there. You can also, of course, just press the hold, and you can press the hold while you have a hold in there, and it will be kept held. And then the output, there is a Braids oscillator down there with this Y output, just modulating the timbre for some difference in the voice. And once we insert the output into the volt per octave of the oscillator, we have this very normal, typical sample and hold sound. We can directly discuss the max and minimum. So this is if you want to remove some of the high notes, you basically just remove the highest notes. If you want to remove the lowest ones, you do that. You just have the high notes. And you can hone in something like this, so you just have a few notes. And if we go into the braids, you won't see this, but I am going into the braids, turning on quantize, trying to ionic, and we can get the nice melody going here. So back here we can instead take, if we take the Y output of the marbles and put into the sample input, and we turn this to plus 5 volts, we can get all positive 5 volts, and when this one turns red, you hear it just stops there, and that's when you need the external plus and minus 5 volts. And now we get the whole range. And again, even here we can also, what we actually do, we don't just constrain it, we quantize to these notes. So again, so staying in here. If we instead go into track and hold, and then we hold, when we hold whatever tone we have at that moment, and when we release it, we just pass the input signal through to the output. So we still get a bit of gliding here. And when we're in the track mode, these still work the same, but here comes a really fun extra feature that happens because math, I guess. That is, if you take the minimum value above the maximum value, it actually starts to twiddle and twirl in a really strange way. Here we're using a triangle LFO and doing it backwards, and we can even remove the hold and it will just see here what this triangle does. So that's a fun little extra feature. You can also use this as a noise source. If you put it in track mode and internal noise, and you plug this output directly into a mixer or audio, and you turn these back like so, you will get a nice noise source. However, these won't affect the noise as much, mainly in volume. You can of course take this and route straight through to a VCO. You will then get a VCO kind of noise. And this noise you can control with the max and min. And of course, as soon as you press hold, you get whatever value is at that time. And this is what it sounds with hold with the internal noise, where you get the burst of noise in between the notes. So that is basically what this does, all the functions of this module. However, as I said before, there is an alternate function, and because there's so much space left in the code space, so you get into this second function, or Easter egg, some people call it whatever you like. It's another function. You can code your own, and you can, most of these sections you can then alter to your own liking. If you put both max and minimum to the minimum value, and you press and hold the hold button for 5 seconds, or if you have a 5-second long hold trig or gate, that would also work. But and you hold it until this lamp turns off. 4, 5 there. So now we are in alternate mode, and I've added a short or a simple sketch that basically you take this will be the master clock, the hold here, and then whatever you input or the noise will then be a random output in sync with this clock, but it will only output a clock if there is a value higher than this max knob. So let's change to a trig input on the Braids, and let's find the kick, for example. So now when it is in this position, when max is all the way down, we have the hold input, and with the internal noise we would get a gate output on each of these clocks. If we turn this up to about halfway, we should get about half of all the outputs. And over here we should get really few, and down here we should get quite a few. You can also use input, CV input or a gate input here. That way you will only get output here when there's this signal is above, when the input signal is above the value of the max knob. Let's see, there. Now we need to exchange to external plus 5 volts. And now it should be quiet when this one goes really low. And that way you can do rhythmic stuff. You can, it's basically an AND gate, but it's only an AND gate on this beat. So it's a synced AND gate. That's what I would call this, which is very useful in rhythmical sense. If we want to go out of this mode, we turn both knobs to the maximum value, and again we hold this button for 1, 2, 3, 4, 5 until it turns off. And now go back, and we can hear that we are back in sample and hold mode. So that's this module, a fun little module that you can do a lot of stuff with and that you can add your own firmware to. There's, as I said before, there's a lot of suggestions in the firmware, and I will try to do a few more of them because I think there's some that are really cool that I'm gonna look at. In the other videos I forgot to show the speed of this thing. It's very fast. So here you have that typical sample and hold sound used by many. And here's another interesting thing I forgot to say. If you take this down here, you can sweep it until you get below that, and then it becomes sample and hold again. So I'm quite happy with how this turned out. If you have coding skills, please feel free to add to the code or do whatever you want. I think there are quite a few interesting concepts that can be made in this format, in this thing. There will be way more modules with Arduino. That is my way forward now. I realize that I have so many things. I said that in my earlier videos that I wanted to do so many things with the Arduino, but I wanted to wait until I had done them the real way first. And now I've done most things the real way, the analog way, and now I want to dive in and really see what we can do with in the digital world. This was a fun way to start and a good way to show port manipulation. I'm probably not going to use port manipulation for DAC output because it's a lot of components and it's very stable though, but it takes up all the pins of the Arduino, so there's not much left there. We have PWM, we have dual PWM, we're going to look at those. We have DAC chips, of course, and then we have ADC chips for the input. We have lots of things to talk about, lots of things to learn about, and many modules to build, that's for sure. So buy lots of Arduino Nanos because we're gonna need them. Yeah, and these are in the shop now, not this one, this one, the complete one. I think I have 8 in the shop right now. I have more on the way. So if you want one, you can buy one, or you can just build one. They are super easy to just build on a strip board, and I'll do that. Also, depending on how many, this was an idea, I haven't thought it through, but depending on how many interesting features people come up with on this, maybe I have to do a blank panel so people can do their own front panel. That might be interesting anyway, I don't know. I like this, we're gonna continue doing this. Until next time, have fun, take care, bye.